Hi guys, I hope you're all doing well. Today we're doing destroying asteroids. So we're given an integer called mass, which represents the original mass of a planet, and we are further given an integer array called asteroids, where asteroids at I is the mass of the ith asteroid. They say we can arrange for the planet to collide with the asteroids in any arbitrary order. If the mass of the planet is greater than or equal to the mass of the asteroid is destroyed and the planet gains the mass of the asteroid. Otherwise, the planet is destroyed. Return true if all asteroids can be destroyed, otherwise return false. So if we take a look at the examples, in example 1 here, we're given a mass of 10, and the asteroids is this input array, and we would output true because, so one way to order the asteroids is this, where the planet collides with the first asteroid. I guess they decided to rearrange the array this way. So if we collide one by one, then first we have 10 colliding with 9. So then since 9 is less than 10, we would combine them to get 19. Then the next iteration, we reach this 19. But since we now have a mass of 19, we're comparing 19 to 19, and these are the same. So we can just combine them again. So 19 plus 19 gives us 38 for the planet's mass. And then as we go along, then we have 5. And then 38 plus 5 is 43. So we just continue along like that. Then next we have 3. So we would, since 3 is less than 43, we would add that to the 43 to get 46. Then the next iteration, we run into 21, which is less than 46. So we would add it to the 46, and then we would get 67. And since all asteroids are destroyed, we would return true. So in the next example, we would return false. We're given a mass of 5 and this input array of asteroids because they say the planet cannot ever gain enough mass to destroy the asteroid with a mass of 23. So after the planet destroys the other asteroids, it will have 22, which is less than 23, so we cannot destroy the last asteroid, so we would return false. Because no matter how we decide to do this, well, honestly, the best way is to just sort this and go from the minimum to the maximum, because then you're always guaranteed to have the best option at the time, if that makes sense. Like, I don't know why they did it like this. I feel like it's just to confuse you. But like if we sort this, then we can compare 4 to 5, and it's less than 5, so we can add it to 5 to get 9, and then we can go to the next smallest one, which is 4, then compare 4 to, let me just show you actually, so it's less confusing. Let's copy and paste this over, and then let's say sorted is 4, 4, 9, and 23, right? And our mass is 5. So first iteration, we're going to compare 5 to 4. 4 is less than 5, so we can add this and get 9. Then the next iteration, 4 is less than 9, so we can combine it to get 13. And then next iteration, 9 is less than 13, so we can combine it to get 22. Then 23 is more than 22, so we cannot combine it. So the last asteroid cannot be destroyed. So that's why we would return false. And so if you sort it, then I feel like that's the best way to do it, because you can guarantee that you're always going to compare the smallest possible one, and then as soon as you can't combine it anymore, like this number that we've reached is greater than the mass, then we would just return false. So that's how I would do that. So let's copy and paste the input array from example 1, so I can show you an example that does work as we work through it. So let me just sort this myself. Is that right? Let me see. 1, 2, 3, 4, 5, 2, 3, 4. Yeah, okay. And then our mass starts out as 10. So first things first, we're going to sort the array. So we'll say arrays.sort, sorted. And then this problem is like kind of dumb. So like we need to turn the mass into a long instead of an int. And we'll call it planet because we can't also name it mass, but we'll just set it equal to mass. And that's because like if we use mass, then, if we use an integer, then as we continue to add numbers onto the mass, it could possibly have an integer overflow if the number's too big. So we're going to use long instead, so it can account for that. So then next we're going to, because now we have this sorted, then we're going to loop through the asteroids the sorted asteroids, and just check if this value is greater than the planet. And if it is, then we know we cannot combine it, just like how we had in example 2, this 23, it was greater than 23 was greater than 22, so then at that point we would return false. Otherwise, we're going to add that number to the mass, or planet, since we called it planet now, and just continue iterating through. And then at the end, we're going to return true. Hopefully that makes sense, but you'll see as I go through it. So for int asteroid in asteroids, we're going to, remember, check if this number is greater than our planet. So if asteroid is greater than planet, return false, because then we know we can't destroy it. And so if there's even one that we can't destroy, then we just return false, right? Because we only return true if all of them can be destroyed. So then next, after that, we can add that mass onto the planet. So planet is going to plus equal the asteroid. Then we're just going to do this literally for every single asteroid. So the first iteration in example 1, our mass is 10, and our asteroid here, as we loop through, is going to be 3. So since 3 is not greater than 10, we can add it to planet. So we'll call this planet now, actually. Sorry, that confused me for a minute. So then 3 plus 10 will give us 13 now. Then the next iteration, our asteroid is 5. 5 is less than or equal to 13, so we would add it onto planet, and now we would get 18. Then our next iteration, we would get 9. Then 9 is less than or equal to 18, so we can add that to get 27. And then our next iteration, we reach 19, which is less than or equal to 27. So we can add that to 27 to get 46. Is that right? Wait. Yeah, 46. And then our last iteration, we would get 21, which is less than or equal to 46. So we can add it onto 46 to get 57. And then we've reached the end, and none of these, we destroyed all of the asteroids, so then we can just return true. So at the end of the loop, we can just return true, and that should be it. So, oops. Why did I put, okay. Sorry, guys. Okay. So now, okay, the time complexity. Sorry, guys. I feel like I always make these like little errors, but it is what it is. Okay, so the time complexities, we think about what we're doing here, right? So first we are sorting this array of asteroids, and that is going to be n log n, where n is the number of asteroids. So we can make a comment here, n log n. And then this is constant, it's whatever. And then in this loop, we are looping through this array once again. Or not once again, but we're looping through this array and visiting every single asteroid, which is going to be O of n, because we're visiting every asteroid exactly once. And then all the stuff inside here is constant, so it doesn't matter, and then that's constant. So if we add these up, n log n plus n, then that would give us n log n total, where n is the number of asteroids. Okay, and then our space complexity is constant because we don't have any additional data structures in here at all. We just have the input array, which we don't count towards the space complexity. So that is it for this problem. Thank you guys for watching, and like and subscribe if you found this helpful. Bye!